Have you ever wondered how artificial intelligence became an integral part of our lives? Stepping back in time, the dawn of AI can be traced back to the mid-20th century. A man named Alan Turing, a genius ahead of his time, was the first to delve deep into what he coined as machine intelligence. His work laid the foundation for what we now know as artificial intelligence. Fast forward to the year 1956, and AI was officially recognized as an academic discipline. From that point on, researchers, scientists, and enthusiasts alike have been captivated by the allure of creating machines that could mimic human intelligence. But the journey of AI hasn't been a smooth one. It has seen its fair share of peaks and valleys, or as we in the tech world like to say, cycles of optimism and disappointment. There were periods of great excitement where the potential of AI seemed limitless. But these were often followed by troughs of disillusionment, where progress stalled and funding dried up. However, the flame of AI never completely extinguished. Each setback was met with renewed vigor and an unwavering belief in the promise of artificial intelligence. The year 2012 marked a significant turning point. That's when deep learning took center stage, outperforming all previous AI techniques and rekindling interest in the field. Then came the Transformer architecture in 2017, which led to a surge in funding and interest. The early 20s witnessed a resurgence of AI, aptly termed as the AI Spring. This period saw significant advances in AI, with the United States leading the charge. The story of AI is a testament to human tenacity and our relentless pursuit of knowledge. It's about our desire to push the boundaries of what's possible and to breathe life into our wildest imaginations. This sets the stage for AI's dynamic journey, a journey marked by breakthroughs, setbacks, and renewed optimism. But what was the turning point that propelled AI into the limelight? Well, it was a revolution in computational models known as deep learning that rocked the AI world. Deep learning is a subset of machine learning, itself a branch of artificial intelligence. These are algorithms inspired by the structure and function of the brain called artificial neural networks. But here's the kicker, these aren't your ordinary algorithms. They learn from large amounts of data, and when we say large, we mean astronomical. Before deep learning, AI was largely rule-based, and it was up to the programmers to manually identify and code these rules. A daunting task, to say the least. Then, in 2012, deep learning stepped onto the scene and outdid all previous techniques. It was a game changer. It enabled machines to process and learn from vast amounts of data, making sense of the world in a way that was previously unthinkable. Deep learning algorithms don't just learn the rules, they make the rules. They identify patterns and information in raw data, creating their own rules to understand the world. This ability to learn and adapt is what sets deep learning apart and what propelled AI into a new era. But deep learning wasn't the only trailblazer in the AI revolution. In 2017, the Transformer architecture was introduced. This was a novel approach to handling sequential data, and it took the AI world by storm. Transformers revolutionized how machines could understand and generate human language. Think of every time you've asked Siri a question or used Google Translate. That's the Transformer architecture at work. These advancements in deep learning and the Transformer architecture led to a surge in funding and interest in AI research. It was as if the world had suddenly woken up to the immense potential of artificial intelligence. Thus began the AI spring of the early 2020s, a period of rapid growth and innovation. A time when AI started to change not just the tech industry, but the world as we know it. But what exactly does AI encompass? Is it just about robots and self-driving cars? Well, the answer is a resounding no. Artificial intelligence, or AI, is a vast field with many branches, each with its own specific goals and tools. One of these branches is reasoning. This aspect of AI is about developing algorithms that can solve puzzles, make logical deductions, and handle uncertain or incomplete information, much like a human mind would. It's about teaching machines to think, to reason, and to make decisions based on that reasoning. Then there's knowledge representation. This is all about creating systems that can understand, interpret, and use knowledge. It's about enabling machines to answer questions intelligently and make deductions about real-world facts. In essence, it's about giving machines the ability to learn and grow their knowledge base, just like we humans do. Planning is another significant aspect of AI. It involves creating systems that can set goals and figure out how to achieve them. It's about teaching machines to strategize, to plan ahead, to anticipate future outcomes, and to make decisions accordingly. Let's not forget natural language processing. This subfield is all about enabling machines to understand and communicate in human language. It's about creating chatbots that can carry on a conversation, voice assistants that can understand your commands, and systems that can interpret and analyze human language at a deep level. Then we have perception, which is about enabling machines to perceive and understand the world around them. This involves teaching machines to see, hear, and otherwise sense their environment, much like we humans do. And finally, there's support for robotics. This is about creating intelligent machines that can interact with the physical world. It's about creating robots that can navigate their environment, perform tasks, and even learn from their experiences. The ultimate goal of all these branches of AI is to achieve what is known as general intelligence, the ability to perform any intellectual task that a human being can do. As you can see, AI is not just one thing, but a diverse field with many branches and objectives. So, how do AI researchers tackle these complex problems? Well, it's a bit like cooking a gourmet meal. You need a variety of ingredients, a pinch of creativity, and a solid understanding of the culinary techniques at your disposal. In the world of artificial intelligence, these ingredients come in the form of a wide array of problem-solving techniques. One such technique is search and mathematical optimization. This is like the sous chef of AI, doing the heavy lifting in the background. It involves using algorithms to explore different solutions and find the best one. It's like looking for the perfect spice blend that elevates a dish from good to great. Then there's formal logic, the recipe of AI. Just like a recipe provides step-by-step instructions to create a dish, formal logic provides a systematic way for AI to reason and make decisions. It's the structured thinking that guides AI's actions. And let's not forget artificial neural networks. These are the taste testers of AI. Just like a chef tweaks a recipe based on feedback, these networks learn from their experiences, adjusting their approach based on what works and what doesn't. But AI doesn't just rely on computer science, it also takes a leaf out of the books of other fields like psychology, linguistics, philosophy, and neuroscience. Psychology helps AI understand how humans think and make decisions. Linguistics aids in natural language processing, allowing AI to understand and generate human language. Philosophy offers insights into ethics and what it means to be intelligent. And neuroscience? It provides a blueprint of how our brains work, a model that AI often tries to mimic. So, you see, creating AI is a complex and multifaceted process. It's a melting pot of techniques, a fusion of different disciplines. It's not about using a single method or sticking to one field. It's about combining the best of what each has to offer to create something truly extraordinary. The beauty of AI lies in its interdisciplinarity, its ability to draw upon a wide array of fields and techniques. What are some specific traits or capabilities that AI researchers aim for? This question leads us to the heart of AI research. The general problem of simulating or creating intelligence is a complex one. It's not about crafting a single, all-knowing entity, but rather about breaking down the concept of intelligence into manageable subproblems. Each of these subproblems represents a particular trait or capability that an intelligent system should ideally possess. Let's start with reasoning and problem-solving. Early AI researchers created algorithms that mimicked the step-by-step reasoning humans use when solving puzzles or making logical deductions. However, these early methods often struggled with large reasoning problems due to a phenomenon known as combinatorial explosion, where the algorithms became exponentially slower as problems grew larger. Even humans rarely use step-by-step deduction in their daily lives. Instead, we tend to solve problems using quick, intuitive judgments. Achieving this kind of accurate and efficient reasoning in AI systems is still a significant challenge and an active area of research. Another crucial trait that AI researchers aim to simulate is knowledge representation. This involves creating AI programs that can answer questions intelligently and make deductions about real-world facts. A key tool for this is an ontology, which represents knowledge as a set of concepts within a domain and the relationships between those concepts. For instance, in a medical ontology, concepts like disease, symptoms, and treatment would be interrelated in a way that reflects their real-world connections. This allows an AI system to understand and reason about the domain in a meaningful way. To achieve these goals, AI researchers draw from a wide array of disciplines, including formal logic, mathematics, psychology, linguistics, philosophy, neuroscience, and more. It's a truly interdisciplinary field, where diverse perspectives and methods come together to create intelligent systems. These traits form the cornerstone of AI research, pushing the boundaries of what machines can do. And as we continue to refine these capabilities, we move closer to the ultimate goal of creating machines that can perform any task a human can do. It's an exciting future, and we're only just beginning to scratch the surface. But AI is not without its challenges, and the future holds many uncertainties. Despite the leaps and bounds AI has made, it still grapples with some formidable hurdles. One such challenge is the combinatorial explosion in reasoning problems. This is when algorithms become exponentially slower as problems grow larger, effectively limiting their ability to solve complex issues. In fact, even humans rarely use the step-by-step deduction that early AI research modeled. Most of our problem-solving relies on quick, intuitive judgments, a capability that remains elusive to artificial intelligence. Looking ahead, the future of AI is a tantalizing blend of potential and uncertainty. Ongoing research is continuously pushing the frontiers of what AI can accomplish, from understanding and replicating human intuition to developing general artificial intelligence that can complete any task a human can perform. The possibilities are staggering. Yet it's not just about what AI can do. It's also about how we use it. The expanding capabilities of AI open up a Pandora's box of ethical considerations. As AI becomes increasingly advanced, we need to grapple with questions of privacy, security, and the potential misuse of technology. How do we ensure the responsible use of AI? How do we prevent it from being weaponized or used to infringe on individual freedoms? These are questions we must answer as we continue to innovate and explore. Moreover, the AI of the future won't just be defined by our technological advancements, but also by our ability to integrate it into society. How do we ensure it is accessible and beneficial to all, not just a privileged few? How do we mitigate its impacts on jobs and economic disparity? The road ahead for AI is both exciting and fraught with challenges. As we push the boundaries of what this technology can do, we must also be mindful of its potential pitfalls. As we venture further into the era of AI, it is crucial to navigate these challenges, harness its potential, and address its implications. So, let's take a moment to reflect on AI's fascinating journey. We've traveled from the dawn of AI, where pioneers like Alan Turing laid the groundwork for this compelling field of study. We've delved into the transformative power of deep learning, which fueled AI's resurgence and brought us into a new era of technological advancement. We've seen the many faces of AI, from search engines to self-driving cars, and how these technologies are reshaping our world. We've explored the complex techniques behind AI, an amalgamation of logic, mathematics, and even psychology. We've discussed the goals of AI research, which aim to emulate and enhance human capabilities. Finally, we've looked at the challenges AI faces and its future prospects. As we continue to explore and innovate, there's no telling what the future of AI holds for us. Stay curious, stay informed, and let's see where this journey takes us.